Hey guys, it is week 13. Make sure that you're doing the geology warm-ups. I've got this file that'll say whatever unit we're on in all caps, warm-ups and to-do list, and I'll kind of drag it around in whatever week we're on. But remember, we do our science warm-up, the back inside cover, there you go, of our science notebook. At some point, our warm-ups will meet our notes way, way, way down the road. Right? But for our warm-up today, you should recognize this density column from the Edpuzzles from recently. It's asking you to put them in order from greatest density to least. All right, so the fluid and the objects. Notice here on the left are the fluids, and then here on the right are all the objects. Okay, so you can push pause and go ahead and rank them. Okay, so if you already have what you think is there, let's walk through it real fast. The first thing you should have is this bolt. All right, notice it's at the very, very bottom, and think about what a bolt is made out of, right? And then you have honey, and then corn syrup, and then you should have the popcorn kernel, because notice how it's a little bit in the corn syrup, a little bit in the maple syrup. So it probably has the density, like an actual calculated density between the two. All right, you got the maple syrup, and then here it says die. Remember that singular for dice. Like this is a little cube, a little D6, six-sided dice. All right, and if you look real close, right there you can see the dots. It looks like it's a 3 facing us, but it's kind of camouflaged by the milk. Right? But that means it has the same density as the milk as well, okay, because it's not sticking out the top or bottom. But then we have some yellow dish soap, and inside you got that cherry tomato, okay, and it's smack dab in the middle, so it has probably an equal density to it. So like if you're ranking them, you had bolt, honey, corn syrup, popcorn kernel, maple syrup, milk and dye, you should maybe have them side by side. And then dish soap and cherry tomato. Now obviously water is not green. They put some food coloring in there for effect, and it's easier to see because these three things in a row would be hard to see elsewise. But then you have these little beads, and they're towards the bottom of the vegetable oil. So it's water, then beads, then vegetable oil. But when you get to the rubbing alcohol, that stuff is not normally blue. They've dyed that as well. That's the stuff that the doctor will rub on your arm before giving you a vaccination, okay, also known as isopropyl alcohol. Notice the soda cap is completely immersed in it. So rubbing alcohol and the soda cap, which is made of plastic, are going to be the same density. Then you have lamp oil, which if you were going to recreate this, that'd probably be the one thing you don't have on hand because most people don't have an old school lamp anymore. And then you got the ping pong ball on top, which I think kind of looks like a moon. Okay. Some kids told me that they tried this, well, something like this at home, and it wasn't so much a knowledge thing, but more of a technique, right? It's kind of like, let's say you needed some surgery. I'm like, oh, cool, I just watched a YouTube video on that. I got you. And they're like, don't touch me, Miss Melanie. Nope, nope, nope. Knowing what to do and then having the expertise and practice and technique and skill, it's a different thing, right? So make sure that you understand the densest things go to the bottom, the least dense things go on the top, and how this is going to incorporate into Earth's layers. And then you've got your to-do list for the day. Right, so I'll talk about the notes in just a second. The Model of Earth mini project, I will also talk about that in just a little bit, but that's not going to be due until like the end, not the end, right before Thanksgiving break. Okay, and if you haven't finished your density gizmo, knock that out. Remember, that's a lab grade, which is like a quiz grade. And you got a couple of quick Edpuzzles to work through, but those won't be due until the night before I see you next time. Okay. But with your notes, remember they're in my file in Classroom for my science notebook. So I would push pause now and go ahead and write them in, and then I'll talk through them in a second. But you've got this page, which we included previously, see? And then this, if you can print this off, it's on Classroom. It'll be cross-section of the Earth. If not, sketch it. Like start with this looks like a triangle and give it depth, like you would, a cube or whatnot. So just kind of make a general sketch of this, and you can add in detail as we go through notes. Okay, so you're not haven't already push pause and get this written. I'll assume you already have it. Here we go. Okay, up at the top, notice the stuff on the left are going to be the compositional layers. So you look at them, you think they're just simple, as in that's what you would have learned in elementary, and that's true. But they are together for a reason because these, the crust, mantle, and core, are what's known as the compositional layers. What that means is, what is it made up of? Think like music or composition in English. What they mean, sometimes they'll say chemical composition. What is it made out of? What elements or what materials will I find in each of them? Okay, but that's why they're called this. Remember, we had color coded this last week. But in the crust, it may be strange to think, but the majority of the things we find in the crust are composed of oxygen and silicon. It's a lot of other things. Okay, later in the chemistry unit, we'll talk about the periodic table. And there are a ton of things that exist on the Earth, but we look at it percentage-wise, oxygen and silicon make up the most. Like, you're familiar with oxygen as in you need it to breathe in to live, but think about you breathe it out, but now it's in a compound of carbon dioxide, or H2O, all the water in all the oceans, in all the rivers and streams and icebergs and all the things. Okay, plus all the compounds that are in the rocks of the Earth, there's a lot of oxygen. Okay, silicone as well. When you think the beach, like those little grains of sand, a lot of that is silicone. It's in a lot of other things too, but a lot of the rock that makes up the crust has silicone in it. We also use that in computer chips and whatnot, but mainly sand. Think about all the beaches on all the continents on the whole planet. Okay, but because it's made of these things that are non-metals that we'll talk about later, it is the least dense layer. Think about the density column we just did, how the ping pong ball was on top. These things are going to be the least dense material, so they're going to be on the top layer. Okay, but as we go further down, it's going to become more and more dense because the dense things will sink to the bottom. In the mantle, middle mantle, see how they both start with M, you're going to find iron and magnesium. Okay, so iron, like the Iron Age, or you think about like a cast iron skillet, you're roughly familiar with iron. Usually it's got some sort of coating on it because we know that iron rusts. It will also have magnesium, which you may think of in your vitamins, and yes, that's true. Actually, a lot of adults are deficient in magnesium, causes all kinds of neurological and like digestional issues, but I digress. The way you would probably be most familiar with pure magnesium is in fireworks. So the fireworks that when they burst are in a white color, that's magnesium. Every firework has a different chemical makeup. The white ones are magnesium. In 8th grade, they'll do a demo for you with a strip of magnesium burning, okay? When you do more chemistry then. But then you've got the core, right? The core is the most dense, and look at what it's made out of. Of course it's the most dense. It's made of iron and nickel. Okay, notice how we have these abbreviations to the solid? Everything has matched except for iron. Okay, when we get to chemistry, we'll talk about how some of them got their names, but iron has been around just about, we have been aware that it's around as long as humans have been on the planet. And so this is a really old name. So it's based off an old name for it, a Latin name for it, instead of like an English name for it. But this will be the most dense layer because it's made out of metal. And then we go ahead and transition over to the mechanical layers. Remember, we just did mechanical energy. So how it moves, because that's what mechanical energy and how it behaves or how it moves, and how it does those things is directly because of heat and pressure. Okay, so that top layer, see how these all have fancy names, right? Because we're big now, we gotta get fancy. But these are the mechanical layers. So look at that lithosphere, asthenosphere, mesosphere. Obviously, sphere we know is a 3D circle. Okay, but litho, like if you've seen cave drawings, those are lithographs. Okay, litho means rock or stone, and that's going to be the crust, what we think of as crust, but a little bit below it too. This is a solid layer. Think about like standing on the ground. It's solid, but it's broken into what we call tectonic plates that kind of float on the layer below it. Now, would not float like, something in the pool, but right on top of. And tectonic, that word, the word part there means to build. Like think of architect, they design the building. That's what that word piece comes from. And we'll talk about that in great detail later. This asthenosphere, you kind of have to say it like have a lisp. This means weak, which you might think is a strange thing for the Earth, but a good way to visualize the way this works, you see my Starburst note here, is that this is a Starburst mini. Any kind of gooey candy Starburst, Laffy Taffy, now laters are kind of hard. Those Tootsie Pops or Tootsie Rolls that are different colors, anything with this type of consistency is a good thing to look at because you see it's a solid. I can smush it, but it's kind of hard to smush. And notice we'll call it a semi-solid because it's not breakable solid like this. Okay, this has a property called plasticity, and that's not one you've heard before, but it's not hard because you see the word plastic inside of it. So anything that's plastic, like let's say this highlighter, to get this shape, they had to melt the plastic and put it in a mold to let it cool. So heat and pressure. But if I want to be able to deform this piece of Starburst faster, what I can do is make my hands warm, like rub them together, this kind of stuff. And once I have warm hands, it's much easier to smush this, okay, because I'm applying heat and pressure now. Does it make it flow like water? No, but it does make it move, okay? When you've got enough pressure pushing on it, you can distort it and make it move to make kind of a convection current, which is what helps make these lithospheric plates move. Okay, and we'll talk about that more later. Mezzo, if you're a musician, you should know this from like mezzo forte or mezzo soprano, means medium or middle. Right, so that's just kind of the layer down, nothing crazy distinctive about it, but it is also kind of the semi-solid, like think Starburst. Like I have to use some Starburst, it's for science. Right? But distinctions to be made on the inner and outer core. Right? The inner core is solid, the outer core is liquid. Okay? Temperature-wise, we know the further in we go, the hotter it gets. The further in we go, the more pressure. Okay, so if all that's true, the inner core has the most pressure and the highest temperature. But you'll see that it's a solid, so that seems kind of peculiar until you realize the entire Earth is sitting on top of it. Even if it wanted to wiggle and flow like a liquid, it has nowhere to go. It's kind of like when your friends are being funny and they all like dogpile on top of you, or you're like not pre-COVID times, but smushed in like an elevator or something, and you can't like lift your arm up, like scratch your nose. You have nowhere to wiggle. Okay, so it's solid because it is smushed so tight from the weight of the entire Earth sitting on top of you. Okay, but this causes convection currents in the outer because it's a liquid, churning around because the inner core is hot. Remember, convection, hot stuff goes up, cool stuff comes down, makes that circular pattern. And here, since it's metal, and iron and nickel are magnetic metals, iron, cobalt, and nickel are the only naturally occurring metals. Okay, but that turns around and gives us a magnetic field, which helps block some of the bad radiation from the sun. And it's what helps make our compasses work to point north. Okay, it's because of what's going on in the middle of the earth. All right, so you've got this, and then you've got this one. Okay? So I'm intentionally giving you lots of different diagrams just to make sure you're comfortable as they come. So if you'll look at the numbers on here, I'm not going to ask you to memorize any of these. Just know thickness in general. Like obviously the mantle is the thickest, the crust is the thinnest, that type of thing. And then general trends in temperature and pressure, like we just talked about. As you go towards the center, both of those increase. But I have note with this one, they've started to distinguish between the oceanic and the continental crust. Okay. The continental crust is more dense, and obviously the curve is further down. The continental crust, think about the highest mountain, right? That's a long way from the highest mountain all the way down to the bottom of the lithosphere. We'll talk later about oceanic crust being made of basalt and continental crust being made of granite. This one you probably recognize from countertops or from going to enchanted rock. Okay, but overall, general thickness and general patterns of temperature and pressure from this. I don't have much time left on my video, so real quick, once you've got that done, and there's that cross section if you want it, you have two Edpuzzles, right? And you should have a density gizmo that you've finished up. Then you've got this model of the Earth mini project. We will talk more about it later, but you're going to build a model kind of like we have been discussing and talked about how there's the strength of a model and limitations of a model. But this won't be due until A Day the 19th or B Day the 20th. But kind of look through and see what you need to construct. It doesn't have to be fancy. It doesn't have to, be a trip to Hobby Lobby and spend 50 bucks. Look around the house. You have plenty of things. Get creative with it. Some of the best models I've ever seen are just random things around the house. And sometimes they looked at it more as their function instead of making it look perfectly like one of these pretty diagrams. It was more in the function of that part of the earth. Okay, so don't feel limited or don't feel like you have to spend any money. It doesn't require a trip to the store. Okay, get creative. You got some things to fill out, like tell me about why you picked what you picked to use it. You'll put an image, or like if you want to take a video of it to explain it to me, that's fine too. And we'll identify the limitations of the model. How is it not like the real thing?